Welcome. We're going to do task 5.7, but I'm going to concentrate on the last two questions, 9 and 10, where now that we know what it is, we're going to try and prove the law of cosines as well as the law of sines. And we're going to do that using this triangle right here. And you notice angles BA and C, opposite sides B, A, and C. You have an altitude at H, and the distance here is x, so this must be A minus x. So the law of cosines, I'm going to start with the Pythagorean theorem. So I've got two different triangles. So the first triangle is right here, and I can express this as h equals c squared, h squared equals c squared minus x squared. And then the other one I can do is the other triangle, which is right here. Okay, a squared plus b squared is c squared, or really it's a minus x squared plus h squared is equal to b squared. And so that can be written as h squared is equal to b squared minus that other side, a minus x squared. So both of these are equal to h squared. So therefore both of these must be equal. So this expression is equal to this. If we use some algebra and we expand this to a squared minus 2ax plus x squared, go ahead and distribute the negative. We end up with c squared is b squared minus a squared plus 2ax. The minus x squared drops off on both sides. We can rewrite that in b squared in terms of the other terms as b squared equals a squared plus c squared minus 2ax. Now that looks quite a bit like the law of cosines, but the difference is that we have an x here. So we're going to go back and use trig to define x. So the cosine of b, cosine is adjacent, which is x divided by hypotenuse over c. So x is equal to c times the cosine of b. So if we substitute that in for x, we get the law of cosines. B squared is equal to a squared plus c squared minus 2ac times the cosine of b. So you can use that to solve for an angle or for sides of any triangle, right? So that triangle could look like this one, sort of. Okay, where we've got angle B, we've got angle A, we've got angle C, opposite side B, A, and C. And we can use this law of cosines here, where if we're given, say, an angle and two sides, we can solve for the third side. Or if we're given the three sides, we can solve for the angle using that law of cosines. There's another one, the law of sines, which is the sine of b over b is equal to sine of c over c. So this one we can actually algebraically derive also from here, but instead of Pythagorean theorem, we can use some trig. For example, the sine of angle B is opposite over hypotenuse, h over c, and the sine of c is h over b. So if we write that out over here, we can rewrite this in terms h in terms of the other terms. H, if you multiply both sides by c, is c times sine of b, or multiply by b, it's b sine of c. So therefore these two are equal. C sine of b is equal to b sine of c. If we divide both by bc, we get the law of sines. Law of sines is also really useful if you have a triangle. And again, let's say A, B, C with sides B, A, and C. And if you know, for example, two of the angles and one of the opposite sides, you can use that to calculate the other opposite side for the angle. So when you look at this, you've got, oops, let me just move this here. You've got 4 different unknowns. If you know 3 of these, you can plug those. If you know 3 of these, you can plug that in and solve for the 4th. That's called the law of sines.